teacher Nerissa, your learning buddy in this video lesson. Before we start the lesson, kindly prepare your pen and paper, and please be reminded to listen attentively and participate actively. So, are you ready? Great! Let us begin another learning adventure in calculus. For this video lesson, you are expected to state the rules for finding the derivative and apply the rules and differentiation to find the derivative of algebraic functions. So why do we study derivative? What are its uses in real life? Applications of derivatives are varied not only in math but also in real life. In business, the use of derivatives is helpful to compute the level of output at which the total revenue is the highest, the profit is the highest, marginal costs and average costs are smallest, and others. So today, we are going to discuss the rules for finding the derivative.
Rule number 1. The derivative of a constant. Let f of x be a constant function defined by y equals f of x equals c, where c is a constant. Then, dy over dx equals differentiating constant equals 0. Or in words, the derivative of a constant is 0. Example number 1. Find the derivative of y equals 8 plus pi. Since y equals 8 plus pi is a constant function, hence the derivative is equal to 0. That is, dy over dx equals the derivative of 8 plus pi equals 0. Rule number 2. The derivative of a power. Let y be equal to f of x equals x raised to n, where n is a positive integer. Then for every real value of x, dy over dx equals differentiating x raised to n equals nx raised to n minus 1, or the derivative of x raised to n equals nx raised to n minus 1. That is, n is greater than 0. In words, the derivative of the nth power of a variable is the product of n and the n minus squares power of the variable. Or to differentiate x to a positive integer power, take the power and multiply it by x to the next lower integer power. Example number 2. Find dy over dx given y equals x. So, dy over dx equals, the exponent of x here is 1. So, bring down 1, then multiply it by x raised to 1 minus 1. So, it's equal to x raised to 0, which is equal to 1. Let's have another example. Find dy over dx given y equals x raised to 5. So, dy over dx equals the exponent 5 multiplied by x raised to 5 minus 1. So the answer is 5x raised to 4. Rule number 3. The derivative of a constant times a function. Let c be a constant. If f of x is a differentiable function at x, then so is c times f of x. And dy over dx equals differentiating c times f of x equals c times the derivative of f of x. In words, a constant factor can be moved through a derivative sign. So let's have example number 3. Find dy over dx given y equals 2x raised to 6. So dy over dx equals 2 times the derivative of x raised to 6, which is 6x raised to 6 minus 1. So 2 times 6x raised to 5, that is 12x raised to 5. Let us have another example. Given y equals negative 3 over 2 x raised to 8, find dy over dx. So dy over dx equals negative 3 over 2 times the derivative of x raised to 8. So it's equal to negative 3 over 2 times 8x raised to 8 minus 1. So you multiply negative 3 by 8, that is negative 24. Divided by 2, it's negative 12. So x raised to 8 minus 1, that is x raised to 7. So the final answer is negative 12x raised to 7. Let's have rule number 4, the derivative of sums and differences. Let y be equal to u plus or minus b, where u equals f of x and v equals g of x, are differentiable functions of x. Then, dy over dx equals differentiating u plus or minus v equals du over dx plus or minus dv over dx. Or, the derivative of u plus or minus v equals du plus or minus dv. In words, the derivative of sum of a finite number of differentiable functions is the sum of the derivatives, and the derivative of the difference equals the difference of the derivatives. For example, find the indicated derivative. Given y equals 3x plus 9, find dy over dx. So dy over dx equals the derivative of 3x, that's 3. The derivative of 9 is 0. So 3 plus 0 equals 3. So the derivative of y equals 3x plus 9 equals 3. Another example. Given y equals 3x squared plus 2x minus 1, find dy over dx. So let's differentiate 3x squared, that is 3 times 2x, plus the derivative of 2x is 2 times 1, minus the derivative of 1, that is 0. So we have 3 times 2 times x, that is 6x, plus 2 times 1, that is 2. So the derivative of y equals 3x squared plus 2x minus 1 is 6x plus 2. Now let us summarize the formulas that we have discussed. First, the derivative of a constant is 0. Another, we have derivative of x raised to n equals n times x raised to n minus 1, provided n is greater than 0. Another, we have the derivative of c times f of x equals c times the derivative of f of x. And the last one, the derivative of u plus or minus v equals the derivative of u plus or minus dv.
I believe you are now ready to answer some exercises.
So you are going to apply the rules on differentiation to find the derivative of each of the following. Number 1. Find the derivative of y equals 50. Is the derivative equal to a0, b1, c5, d50? The answer is A. The derivative is 0. Did you get it right? Very good. Next, what is the derivative of y equals x raised to 5? Is it A, x raised to 6, B, 5x, C, 5x raised to 4, or D, 4x raised to 5? The correct answer is C. dy over dx equals 5x raised to 4. Next, find the derivative of y equals negative 25x raised to 4. Is dy over dx equal to negative 25x raised to 4, or negative 100x cubed, or negative 100x raised to 4, or 100x cubed? The answer is B. dy over dx equals negative 100x cubed. Try number 4. Find the derivative of y equals 3x squared plus 4x minus 5. Is it A, dy over dx equals 6x plus 5? Or B, dy over dx equals 6x minus 4? Or letter C, dy over dx equals 6 plus 4x? Or D, dy over dx equals 6x plus 4? And the answer is D, dy over dx equals 6x plus 4. Did you get all correctly? Great job!
And that concludes our lesson for today. I hope you have learned something today. Thank you for joining me in this episode. Once again, this is Teacher Nerissa, your learning buddy in this video lesson.